Now we will talk about the secure extension for Java OOAD programming. If the class itself is sensitive, or some of the method is sensitive, or some of the member variable or data is sensitive, then the class should not be extendable. If it has to be extended, then any logic can be defined in the child class without a proper control. Sometimes the subclass is trustworthy, but the subclass may be changed without control inside the subclass. If the subclass trusts too much about the subclass, it may be dangerous to that subclass. For example, the superclass can later be modified to add new insecure public methods or revise the original method to a vulnerable method, which will be accessible to the subclass objects, and subclass objects are not aware of this, and then they will use the vulnerable method. There are a few ways to address this type of insecure extensibility. For example, one way is to define the immutable class as a final class, so it cannot be changed or extended. The other approach is to have a Java Security Manager check the security controls before the call of a Schubert constructor. It is critical that the call of Java Security Manager check must be done before the object initialization in order to prevent the called finalizer attack. Or simply, the call of Java Security Manager check should be done as the first statement in the constructor. Please be aware of that Java Security Manager check in the subclass may not work because the subclass constructor will always be called before any statement executed in the subclass constructor. Thus, the Java Security Manager check will be called after the object is partially initialized, which can be exploited by the finalizer attack. And we will talk about that soon. A sensitive method can also be defined as a final method, so it cannot be extended or overridden. We will use the example, the mass big integer class, which is not a final class and thus can be extended and make it vulnerable. That is why even though Java is considered as a safe programming language, it may be not secure at all. In the Java library, there are a lot of classes defined without putting security in mind, and thus this library have no security control. So the application developers should study the library class and design security control by the application developer. An untrusted client may override the library class member class. In this example, the myBig integer class 0, 1 is the subclass for the mass dot big integer class, and it can have a dangerous set value and a vulnerable overridden mod PAL method, which is very useful for defining critical algorithm for some critical missions. As we have discussed before, the application developer can use the Java Security Manager to control the potential security vulnerabilities. However, in OAD, a security manager itself may be still vulnerable due to the poor programming. Assume that the security manager is defined in a constructor or other method, which may throw an exception, leave the object partially constructed. Subclass of this class can override the finalize method to save a reference. Of the partially constructed object, the Java garbage connector will not perform the connection until the final method finish. So the overridden finalize method can steal the partially initialized object to perform or even bypass the security manager check. So this is called finalize attack. How to define such finalize attack in Java programming? One way we can do is to make the security manager check as a private static method, which is supposed to be invoked before the superclass construct code, or so there will be no object initialization without the security check. As here, we have the check as a private static method. Please note that in the Java, the static variable members are initialized before any other statement and the parent constructor call in the constructor. And the static method will be called before the call of a super constructor. Overall, to control the insecure Java OAD extension, application developer can define the class as final or define the security manager check as a static method and private, and call the check method as the first statement in the constructor. Now let's take a look at the Java example. This is the non-compliant program, and we do have a set value method and we do have a overridden mode PAL method. This method is not precise and is thus dangerous. In the compliant solution, we will have a specific class check to determine whether the object is the original mass big integer class. If it is not from the trusted library class, then make a defensive copy of the object for potential change. This is pretty much about the secure extension for Java OOD programming.